Hello everyone, I am Prem Kumar. Welcome to Math JEE Academy. Today I am going to discuss with you a very interesting concept. So many of the students are facing difficulty in that. Okay, so what is that one? Principle of inclusive and exclusive. Okay, that means inclusive means adding and exclusive means subtracting here. Okay, so before going to discuss that, so we have to understand that idea about the at least exactly one set, exactly two set. Okay, so we'll discuss about that principle first, and then we'll discuss about the inclusive and exclusive, that means adding and subtracting. Okay, first we'll discuss about the first. You can see the number of elements in A union B is equal to n of A plus n of B minus n of A intersection B. I will explain through the Venn diagram, right? You can see the first set. What is that? First set you can see, this is your universal set. Let's take this is universal set. Let's take this is A. This is your B. Okay. So A union B means what? You collection of all either A or B. That means at least A or B. That's A union B, right? So how to write equivalently? So first you can write the shaded region first. This is your A union B, right? A union B, right? So how to write equivalently? First I am collecting all the, first what I am doing first? First I am collecting all A, right? All A means this portions. Okay, next you can see, this is your B, complete B, right? This is A, this is B. You can see when you take A, you're including A intersection B here. This is A intersection B, common. A intersection B means what? Common of these two set. Okay. Here when you take B part, again you are including A intersection B, right? So if you need A union B, so what you can do, you have to one times you have to add the A intersection. Here you have to two times your you can see included. So you have to include, you have to exclude one time, right? That is the inclusive. You can see you're adding and subtracting here. Understood? Why we are subtracting A intersection B? Because you're adding two times. When you take A, n of A, intersection added, and when you take B, intersection added. But when you take A union B, so A intersection B occurred. So therefore, so you have to remove one time, right? Clear? So therefore, you can see one time you had to subtract it. So you're adding two times, right? You have to subtract one times. This is the formula, right? Okay. Clear, all of you? Fine. Next, we'll discuss the n of A minus B is equal to n of A minus n of A intersection B here. So you can see, student, the first observation, this is your set A, this is your set B. So A minus B means what? A minus B means, you can say this is your A minus B. That means A and B is there. Now you have to collect the common elements. You have to remove from A. That is A minus B. So A is the whole thing and remove the A intersection B. That is A minus B. This is your A minus B. Right? B minus A is what? This portion. So this is your B minus A. Clear? So n of A minus B equivalently how to write? So we can write the white color whole region is there, no, that is n of A. You remove the n of A intersection B, this is equal to n of A minus B. Understood? The same way that a red color portion shaded region is required means, that is n of b minus a is required means, what is required? Total b you have to calculate, remove the intersection. Total b, you remove the a intersection b. Clear? Okay. And the third one is done. Fourth one you can see a delta b, it's a asymmetric difference of b. What is the meaning actually? You can see, you can write a minus b union b minus a, you can write. Correct? Understood or not? The symmetric difference of a and b will be a minus b union b minus a. So this is equivalently how to write. You know that union means or addition n of a minus b plus n of b minus a, you can write. So n of a minus b, how to write? You can see n of a minus n of a intersection b, you can write, plus n of b minus a, how to write? N of b minus n of a intersection b. You have to remember, student, whenever they are asking a minus b, you can see first a minus b, you are subtracting b from a. So you have to see what is common between a and b. You have to remove the common things from a. B minus a means common of a and b, you have to remove from b. Understood? Okay. So now you can simplify this, n of a plus n of b minus 2 times, you can see how to write this one, 2 times n of a intersection b, you can write. Okay. This is another way how to write, you can see another way. So n of a union b minus a intersection b also we can write. This is same as that one, right? Because a union b formula is what? So n of a plus n of b minus n of a intersection b. So this is equivalently how to write? N of a plus n of b minus n of a intersection b minus n of a intersection b, we can write. You know, this is same as what? N of a union b. A union, whenever they are using union, you have to use or. In words, how to write? At least one of a and b. At least one. Understood? Whenever at least you are using, no, that is you have to use the union, right? Okay, a union b minus n of a intersection b, you can write. So all are same only, right? I hope everyone understood, right? Okay, fine. Let me take another one. You can see n of a union b union c. How to write? You can see, student, whenever a union b union c, what is the meaning? At least one of a, b and c, right? At least one of them, right? That's the meaning. This is at least one of a, b and c. Okay, first you can understand through the Venn diagram. This is set A, this B, C. This is A, this is B, you can take this is C. Okay. Now, okay, student. First, what you can do? First, I am collecting all A. First, all A is what? All the A, right? And then if I take all the B will be what? All the B. This is all the B. All the C will be what? I am taking this one. All the C. Clear? So we need completely A union B union C. That means whole thing is required. All the A union B union C is required. First, I am collecting n of A. So when you collecting n of A, you're adding A intersection B here, right? This is, you can see here, when I join, this is A, this is B, this is C, this is A, this is B, this is C, this is what? A intersection B. Let me take this one, this is B intersection C. Take another color, this would be A intersection C. Clear? So when you take complete A, you're adding A intersection B, right? When you take complete B, you're adding A intersection B again. Understood? So N of A plus N of B plus N of C you can take, minus, when you take A, one times adding A intersection B, no problem. But when you take B, again A intersection B are adding. So you have to subtract one time. N of A intersection B. Okay. And when you take N of B, you can see N of B, you can see when you take N of B, A intersection B added. Okay, fine. When you take N of C, you can see N of C, if you take, what are the things you are adding here? B intersection C, right? When you take B completely, so B intersection added twice, so you have to subtract one times, B intersection C. When you take this portion, when you complete C portion is there, no, you can see. So A intersection C, right? So added two times, right? So you have to subtract one times, A intersection C. And you can see we need A union B union C, still it is not covered, right? Which is not covered? A union B union C, you can see here. This is your A, this is B, this is C, right? So A union, so let me take another color. This is your region is covering A union B union C. This is A union, sorry, A intersection B intersection C, right? That should be added. N of A intersection B intersection C. Clear? Because then only you can get the union part, right? I hope everyone understood. What do you have to do? First you are collecting all the A. All the A means what? Which portions you are adding here? A intersection B and A intersection C you are adding. And when you take B, A intersection B and B intersection C you are adding. When you take C, again you can see A intersection C, B intersection C you are adding. Two times adding, you are subtracting one times. One times A intersection B, one times B intersection C, one times A intersection C. And this portions is middle one is there, no, that is common of all the three sets that you have to add it, right? Then only you will get whole unions, right? Okay. So this is actually inclusion-exclusion principle we can use here. So you're adding A, B and C, right? The whole thing you can see adding one at a time. Let's take S1. S1 is what? S1 is what? Adding taken one at a time, you can say, right? Sum you can take. Sum taken one at a time. S2 you can take sum taken two at a time. right? S3 you take, S3 you can take here. What is S3? Sum. You can see the 3 at a time, right? Clear? So that means you can say A intersection B intersection C here. Then how to write? So n of A union B union C you can write as S1. Let me take this S1 minus, you're adding the sum taken 2 at a time means what? N of A intersection B plus n of B intersection C plus n of C intersection A. This is taken 2 at a time. 1 at a time is n of A plus n of B plus n of C, right? And you have to subtract it. So adding, understood? S1 is inclusive. You're adding this and subtracting 2 at a time, sum, right? That is S2 plus S3. This is called inclusions and exclusion principle. Inclusion means what? Adding, and exclusion means subtracting. Understood? Okay. So let me take another one. So second, you can see the number of elements, exactly 2 of the sets. 2 of the sets, what you can do here? You can see, student, exactly 2 of the sets. First, you have to understand through the Venn diagram. This is suppose A, this is your B, this is suppose C you can take. Clear? Okay. Exactly 2 of the sets means what? Which portion is covered here? Exactly 2 means this portions. Exactly 2 of the sets. This is one. Let me take another color. Exactly 2 of this. Okay. Okay, next, this portion. Exactly 2. Understood? Okay, fine. Exactly A, B only is there. You can see here pink color. You can see B and C only is there. Here A and C only is there. Exactly 2 sets. Then how to rewrite this, students? You can see first you can take the n of A intersection B. A intersection B means what? You're including A intersection B intersection C, right? This portion is what actually? This portion is A intersection B intersection C, all common, right? When you take A intersection B, A intersection B intersection C included, right? This is completely covered. We need only red color portions. So you have to subtract 1 times A intersection B intersection C. This is for red. Okay. This is for red, right? Next, second one is add these 2 things. Pink color is required. Pink color is required means B intersection C you take. B intersection n of B intersection C, number of elements in B intersection C means again you can see you're including A intersection B intersection C. You have to subtract that one because we need only pink color, right? N of A intersection B intersection C plus green color. You can see only green color required, then only you can get exactly A and C you'll get, right? That means A intersection C, you remove that A intersection B intersection C part. N of A intersection B intersection C. This is for your green color. Okay, now you can add all the things. What will get? N of A intersection B, right, plus N of B intersection C plus N of A intersection C minus how many times you are subtracting? 3 times, right? 3 times N of A intersection B intersection C. This is your formula, right? This is exactly 2 of the sets. Clear? Okay. So, let's understand the another one. You can see the number of elements exactly one of the set. You can see, student, first you can draw the Venn diagram. This is universal set. Let's take this is A, this is B, this is your C. Clear? Okay, fine. So exactly one set is required, means which portion is required, which one is required, you can see the shaded portions only. This is completely A. You can see next completely B, you can see this is your completely B. Next you can see this is your completely C. Exactly one of A, B or C. Okay, that red color portions how to write, you can see. So N of A you can take N of A. So N of A. First I am collecting all the N of A first, and then you can see we need the red colors only. Which one you have to subtract it here? You can remove the A intersection B and A intersection C, correct? A intersection C, correct? You have to be very careful. I'm just taking whole complete A. We need complete red color regions only. First I'm whole A I'm taking and removing A intersection B, right? When you remove the A intersection B, you removed A intersection B intersection C. You can see when you removed A intersection C, again you can see A intersection B intersection C, you had to remove 2 times, right? That means you have to add 1 times. 2 times you remove, 1 times you can add, right? A intersection B intersection C. Clear? Next, same way, whole B you can take plus N of B. Whole B you can take, we need only the green color. So whole B you can take, you have to remove the A intersection B, N of A intersection B, and remove this B intersection C, B intersection C, B intersection C, and 2 times you are subtracting, you have to add 1 times, N times A intersection B intersection C. Clear? Now we need the violet color. So what we can do, take N of C, whole C you take, and remove the first B intersection C, and remove the A intersection C. We need only the violet, right? That's why we are removing these portions, right? A intersection, B intersection C, A intersection C. Okay. So 2 times you are subtracting the common things. So you have to add 1 times, right? Clear? Now you can simplify this. Finally, what will get? N of A plus N of B plus N of C. You can see, student, N of A intersection B, N of A intersection B. How many times you are subtracting? 2 times. Minus 2 times N of A intersection B. Okay. And then next you can see B intersection C. 1 times here, 1 times. Minus 2 times N of B intersection C. Next you can see one more thing. A intersection C. Here 1 time, here 1 times. Minus 2 times N of A intersection C. How many times are adding A intersection B intersection C? 3 times, right? Let's take 3 times N of A intersection B intersection See here. This is formula will work for exactly one of the set. Just we can see in the screen, right? Red region, green region and violet regions. I hope everyone understood, right? Okay. Let's do the another one. So you can see this is your De Morgan's law. N of A complement union B complement is equal to N of A intersection B whole complement is equal to N of U minus N of A intersection B. Understood? You can see this is, you can do it easily, right? If I take the set, universal set, this is your set A, this is set B, right? So A intersection B, if you remove it, you can see A intersection B, this portions, right? The whole union, you remove the A intersection B, then you will get A intersection B whole complement, right? You can see the Venn diagram, you can easily do it, right? So how to, this is called De Morgan's law, right? A complement union B complement means union changes to intersection, the whole complement. So A intersection B whole complement, how to write? N of U minus N of A intersection B you can write. That means the whole universal set, remove the A intersection B, right? Okay, the same way A complement intersection B complement you can write as N of A union B whole complement you can write. Here intersection changes to union. So this is same as N of U minus N of A union B. So I hope everyone understood this. This is very simple only. Okay, let me take another one. Hello student, we'll continue this one. The law of difference of the set A minus B is equal to A intersection B complement. So what is the meaning actually? You can see here when you take the set, let's take this universal set, this is A, this is B, A minus B, this will be this one, right? This is A minus B. So okay, this is equivalently how to write A intersection with the B complement. You can see in the diagram. So let's take, this is A, this is B, right? The B complement means what? Except B, right? Remaining everything will be there, right? You can see this is your B complements. Intersect with A. Intersect with A. This is which portion is a common region here? B complements, that means complete red color. So which is common region? You can see the common region here is this one, right? So therefore we can say A minus B is equal to A intersection B complement we can write. Fine. The same way B minus A is equal to B intersection A complement we can write. Okay. So A minus B, how to calculate? You can see A and B are common, right? So you have to remove the commons from A, that is A minus B. B minus A means what? A and B common you have to collect first and then you can remove the common from B, that is B minus A. Okay, so A minus B you can see this is a subset of A, because A minus B is the, you can see here it is the red color region is completely within the A. So definitely A minus B is a subset of A. The same way B minus A. B minus A is what? You can see this is your B minus A. This is your B minus A. This is your A minus B. So B minus A within the B, therefore B minus A is subset of B you can say. When A minus B is equal to A, because you can see A and B, anything is common is there or not, you have to check it, right? So there is no common means definitely you can see A minus B will be A only. Understood? Because there is no, that means you have to remove common. Common here is empty only. There is no common elements. You remove from A, that is A minus empty set is what? A only, right? Okay. Let me take another example here. A minus B union B is equal to A union B, right? Because you can see the screen in the A minus B, this one, you have to union with the B. B means completely A intersection B also included. So you can write A union B, you can write. So A minus B intersect with B. There is no common element from A minus B and B minus A, right? And if A minus B is completely different from B, therefore intersection is empty. So already we discussed this property, A minus B union B minus A is equal to A union B minus A intersection B, you can write. Okay, next let us discuss this one. You can see the group of 100 students, 60 like mathematics, 50 like physics, 40 like chemistry, 30 like both mathematics and physics, 20 like both physics and chemistry, 25 like both chemistry and mathematics, and 10 like all three subjects. Okay, so then how to write in mathematical notation? You can see here, student. So first you can write M here is mathematics, N of M is equal to 60. Let us take physics is N of P is equal to 50. So N of C is chemistry, this is 40. So N of M intersection P, this will be 30. And P intersection C, N of P intersection C is what? 20. C intersection M, N of C intersection M is what? C intersection M is 25. And all three subjects, that means what? N of M intersection C intersection P, this will be 10. Now what is the first question? Find the number of students who like exactly two subjects. Exactly two subject means, so which one we already have the formula, right? You can see we discussed already. You can see here, this is exactly one, exactly two only, sir, right? Exactly two. So that means A intersection B, B intersection C, A intersection C minus 3 times A intersection B intersection C, you have to do it. We already discussed this, right? Okay. So A and B, B and C, C and A, and remove that all three, right? You can use that formula here. Okay. What will get? First one you can see N of. So first is what? Mathematics and physics, and N of physics and chemistry, and plus N of chemistry and mathematics, right? Correct? And remove the 3 times N of M intersection C intersection P. Calculate this one. M intersection P is how much? It will be 30. P intersection C is 20. C intersection M is 25 minus 3 times M intersection C intersection P is what? 10. Then 30 plus 20 is 50 plus 25 minus 30. So 50 plus 25 is how much it will be? 75 minus 30, right? 75 minus 30 is 45, right? 45 students like exactly two subjects. Understood? The same way you can apply for the number of students who exactly one subject. You can use that formula, right? What is that? N of A plus N of B plus N of C, right? So you have to remove the 2 times n of A intersection B, 2 times n of B intersection C, 2 times n of C intersection A, right? Understood or not? So you can add, you can see exactly 1 means you can see here. So you subtract it and add 3 times n of A intersection B intersection C, that is for exactly one of the things, right? Okay. Okay, fine. I hope you can do it, right? So you can do it yourself. You can use this formula. You can complete this one, right? So here n of P, n of M, n of C, and subtracting the 2 times each of the things and add 3 times, okay, all common, right? That is exactly one of the subject. Okay, fine. So let me take another one. Inclusive-exclusive principle will take more example. You can see A union B is equal to, so cardinality also you can say, or number of elements of A union B also you can say. N of A union B or cardinality of A union B, both will be same. So coordinate of A, cardinality of B minus cardinality of A intersection B you can write. S1 is what? Sum taken one at a time. S2 is what? A intersection B here. So S1 minus S2 is the including. This is adding or subtracting? Alternate sign, right? Okay, fine. So hello students, we will continue this. You can see 3 set is there. You know how to use the inclusion and exclusion principle here. You can see what is the A union B union C, how to write? First you have to understand this one quickly. So cardinality of, let me take this color, cardinality of A union B union C, how to write? Cardinality of A plus, that is n of A or n of B, right? N of B plus n of C minus, you can see the, you are taking all elements in A means you are including A intersection B, right? Understood? So 2 times you are including, you have to remove 1 times. That means A intersection B 1 times, B intersection C 1 time, and C intersection A, and add the common A intersection B intersection C. This is your formula, right? We already discussed about this using the Venn diagram, right? Now the sum of S1 is what actually? Sum taken at 1 time, and S2 you can say sum taken 2 at a time, right? Sum taken 1 at a time you can say, right? Here you can write 1 at a time. Sum taken 1 at a time. So sum taken 2 at a time. Okay. This means what? A union B or B union, you know, B intersection, sorry, here A intersection B, B intersection C, and C intersection A. 2, right? 2 at a time. Here 1, right? So adding all the things, right? And S3 you can see A intersection B intersection C. Then how to use this one? B union C, S1, the sum 1 at a time minus 2 at a time, S2 plus S3. This is inclusion and exclusive principle. Subtracting, that is, you know, inclusive means what? Adding, exclusive means subtracting. Understood? Okay. Using this idea, let us discuss the problem. Okay. Let me take the first question. Find the number of positive integers less than or equal to 2076 and divisible by neither 4 nor 5. So that means what? If you consider A is the number of numbers divisible by 4 you take, B you can take number of numbers divisible by 5 you can take. What they are asking actually, neither 4 nor 5. That means the complement they are asking. A complement intersection B complement, right? Okay. Let's take the first question. You can see the first one, how to do this. Let's take A. You can see the total number of natural number. You can say number of numbers divisible by 4 you can take. You can see the screen 4. And B, you can say number of numbers divisible by 5. So both should be, you have to take from all the natural number from 2000, from 1 to 2076 only you have to take. The maximum you have to take 2076. Okay. So here, universal set. What is U here? The maximum possibility 2076, right? Okay. So what they are asking actually, A complement neither divisible by 4 nor divisible by 5. That means A complement intersection B complement they are asking. You can use the De Morgan law. The intersection changes to, how to write? A union B whole complement you can write. So using De Morgan's law, right? Okay. This one how to write? N of A universal set minus A union B you can write. Or you can write cardinality of U minus cardinality of A union B you can write. Cardinality is number of elements, right? Okay. Clear, student? First your target is how to find A union B. You know that formula. A union B, how to write? A plus cardinality of B minus cardinality of A intersection B. First, how many elements are divisible by 4 you have to calculate, right? How many numbers? You very shortcut method how to find the how many numbers are divisible by 4 from 1 to 2076. 2000, the maximum number you can see 2076 only, no? 2076. 2076, right? Okay. Or how many natural number divisible by 4 from 1 to 2076? How to calculate quickly? So using the greatest integer function. You know the greatest integer function is a function from real number to integer. You know how many integers value is possible, right? How to calculate this? Before that, you have to understand the greatest integer function always less than or equal to x. For example, if I take 1.5, the greatest integer 1.5. So 1.5 is not an integer. Which is the greatest integer less than 1.5? It is 1, right? So therefore, greatest integer function of 1.5 is 1. Minus 1.5, greatest integer is minus 2. Clear? Okay. Take the large number, that means last number you take, 2076 divided by 4 you can do it. So how many numbers which are divisible by 4 from 1 to 2076. This is a shortcut method to find the number of digits which is divisible by 4. Suppose divisible by 5 means 2076 by 5 you can do it. Then do it. So what is the answer? 2076 by 4. How much it will be? So 519, right? So approximately you can see 519 point something will come. So the greatest integer will be, so 51 only. So you can multiply 519 into 4. $2076, right? Yes, good. Exactly 519 you'll get. Therefore, the greatest integer value is what? 519 only, right? Okay. So fine. So next you can calculate the cardinality of B. 2076 by 5 you can take. Then what's your answer? You can see here 415.2 you'll get. This is approximately 415.2. What is the greatest integer function of 415.2? 451, right? 415. Clear? Okay. Next we need to calculate what is cardinality of A intersection B. How to calculate? Both A and B occur simultaneously. What is the meaning? 4 and 5. That means it is divisible by 4 and 5 means what? What is the LCM? Right? It's 20, right? So you have to divide this 2076 by 4 into 5. You take this. We need the number which is divisible by 4 and 5 is required. So you take the LCM of 4 and 5. So LCM of 4 and 5 is what? 20, right? Yes. Then you can take this. What is the possibilities? 1 or 3.8 will come. 1 or 3.8. So greatest is the 1 or 3.8. So what is the greatest integer function of 1 or 3.8? 1 or 3. Understood? So how many numbers divisible by 4 means from 1 to 2076, 519 number is there. How many number divisible 5 means 415 number. How many numbers divisible by 20? But they are asking actually what? Divisible by 4 or 5, right? Understood? So this answer is what? 1 or 3. Both will be occur means 1 or 3 numbers are there. Now you can apply the inclusion-exclusion principle, right? Here what will get, you can see cardinality of A union B is equal to cardinality of A plus cardinality of B minus cardinality of A intersection B. You can take, what is cardinality of A? 519 plus B is 415 minus, this is 1 or 3. Substitute, what is the value? You can see 519 is 415, you can do it. How much it will be? So 14 or 3, so 934, right? Okay, 3 and 934. 934 minus 1 or 3. How much it will be? 1 or 3 if you do it. 4, 1. So 3, 9, 1 if you do it. 831. Is it correct? 831, 4, 3 and 934. Yes. 831, right? This is for A union B. Number of elements in A union B. What actually is required? What actually is required? A complement intersection B complement. Neither divisible by 4 or divisible by 5. correct? That means A complement intersection B complement is required. So we have to substitute it here. Substitute, what will get? Tell me. The total number here is what? The universal side here 2076 minus 831, you can do it. 2076, 831. If you do it, 6 minus 1, it is 5, 7, 3. If you do it, 4. So here is how much it will be? 1911. Correct? So 1145, 831, you can do it. 6, 7, 9, 1, 9, 6 is coming. So that means 12 will come. Right? 1245. That means how many number is possible? 1, 2, 4, 5 numbers is possible. This is your answer. I hope everyone understood, right? Is it correct or not? You check once. 1, 2, 4, 5, 1, 2, 4, 5 and 831, you can do it. 6, 7, yes, 2076, yes, work. 1245 numbers is possible from 1 to 2076. Among this, how many numbers which is not neither divisible by 4 nor 5? 1245 number is possible. Okay, let's do the next question. You can see, find the number of positive numbers less than or equal to 3076 or not divisible by 24. Not divisible by 24. So how much it will be? You can see, student. Next question. So let me take 3076 not divisible by 24. The same idea, you can do it. So first you find the total number of numbers. 3076 number is there. You remove the divisible by 4, you can do it. Okay. So what you can do here, 3076 is the maximum. Second board, 3076. Okay. So what we have to do, how many numbers which is not divisible by 4? How many numbers not divisible by 24? That means total numbers minus the number of numbers divisible by 4. Divisible by 4. The total number of number is what? 3076 minus number of numbers divisible by 4. Divisible by 4, what? 24, sorry, 24. So the greatest integer function of the large number is what? 3076 divided by 24. Calculate this. 3076 minus, so 3076 divided by 24. How many times is possible here? 128, right? 128 into 24, you can check it. $124, no? Two 7 3072, right? Yes, 128 point something will come, right? So this is 128 point something, right? Okay, so therefore 3076 minus 128 point something, greatest integer value is what? 128. Then 3076 minus 128, how much it will be? So 8. Here is 6 is there, 6 2, it's 4. Here will be 129, 2948. Check once. 128 can add it, 16, 7. Yes, correct. Is true. So what's your answer? 2948 is your answer. How many numbers not divisible by 24 if they ask? The total numbers minus number of number which is divisible by 4. So how to find the number of number divisible by 4? You can take the larger number divided by 24. So what is the greatest integer value? That is the number of numbers which is divisible by 24. I hope everyone understood, right? Okay, next you can do the next question. You can see, find the positive integer less than or equal to 3000 and is divisible by 3, 5 or 7. This is very simple. You can see divisible by 3, 5 or 7. Here or is there. That means you have to use the union. That means at least 3, 5 or 7 they are asking, right? Okay. Now you can see, student. Next question. You can see 3000, right? 3000. So how many natural number is there from 1 to 3000, and which is, the question is what? How many positive integers? That means you can see the natural numbers is less than or equal to 3000 and is divisible by 3, 5 or 7. So let us take A is divisible by the number of number divisible by 3, 5, 7. Let's take A. Number of numbers divisible by 3 you can take. B you can take number of numbers divisible by you can take 5. And C you can take number of numbers divisible by 7 you can take. Okay. So what they are asking actually, A union B union C, that is only they are asking, right? So you know that this is same as n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. Okay, this is the inclusion-exclusive principle, right? So you're adding, that is inclusion, subtracting, that is exclusions, right? Okay. You can take, this one is S1, you take minus common, that is S2 plus S3. So we need to find out this. First let us find out cardinality of A. Okay. So tell me, the larger number is what? 3000 divided by, divisible by 3. How much it will be? 1 times here 1000, right? Correct? You can check once, 357 or not. 357 only. 3000 by 3. Is it correct? Yes. Fine. Next B. Cardinality of B, you calculate 3000 divided by 5. 1 times here, 6 times, 600. The greatest integer's value is what? 600. This is 1000. Cardinality of C you can calculate. The greatest integer function of 3000 divided by 7. You can calculate how many times is possible. 428.7 will be possible. 428.7. 428.7. This is 428. Clear? Now you have to calculate the A intersection B. A intersection B means what? It is divisible by, you can say here, A intersection B means what? Or you can say number of numbers divisible by 3 and 5. 3 and 5. That means what? The LCM you take 15 you can write, right? That means 3000 divided by 3 into 5. You can see here. So here is 1000. 1 times here is 200, right? Is it correct? You can see 3000. So 3 into 5, right? First, and then you check once clearly. So 1 times here is 1. This is 1000 times 3 is 3000. Correct? 5 you can take 200 times. Yes. So the greatest integers function of, here you have to take greatest integer functions, right? That is 200. Okay, next, greatest integers, what is that? B intersection C is required. How many number is there? B intersection C means, you can see divisible by 5 and 7. That means 5 into 7, so LCM, right? 3000 divided by 5 into 7, you can take it. So what is that? You can see quickly. 3000 by 3 into 7, 142.85. 142.85. 142.85. This is 142, right? Then C intersection A. 3000 divided by C intersection A means what? It divisible by 3 and 7. 3 and 7. That means take the LCM of 3 and 7, right? So you can see this value is exactly 85.71. 85.71. 85.71. This is 85. Now you can substitute everything here. Now you can substitute what will get, you can see here, student. So we need this one, A union B union C. So cardinality of A is what? 1000 plus B is 600 plus C is what? 428. 428. And then subtracting minus 200 and subtracting the 142, subtracting the minus 85, plus one more you need to calculate, right? Cardinality of A intersection B intersection C you have to calculate. You have to add it, no? So 3000 divided by, so you need to multiple of all 3, 5, 7, right? Take the LCM of 3, 5 and 7. You take this, the answer is 3, 5, 7. If you take 28.57. 28.57, right? 28 point. The greatest integer function of 28.57. This is 28. Clear? Now you can add the, what is that? 28. Now you can simplify this one. How many numbers which are divisible by 3, 5 or 7, right? So why we are taking A intersection B, B intersection B? Because either A or B only is required, 3 or 5 or 7. So it will not be multiple of 15. It will not be multiple of 35. It should not be multiple of, you can see 3 and 7, no, first and last. It multiple of 21. We need exactly either 3, 5 or 7. So you have to remove the multiple of 15, multiple of 35, multiple of 21. So that's why we are subtracting this. That is inclusive and exclusive principle, right? Using that we can find out. Then do it quickly. The calculation is what? 1600 plus 428. How much it will be? 8201. 2028, right? 2028 minus, you can see, so 200, 142, how much it will be? 2, 4, 342. 342 plus 85, how much it will be? You can see 7, 12, 1, 427 minus 427. Correct? I am doing correct. 342 plus 85, 7, 4, 2, yes, what? 427 plus 28. How much it will be? 2028. So I will write here plus 28. How much it will be? 502056, right? Minus 427. 427 you can do it. 16. So 9, right? 16, 10, 6. Yes, correct. Here will be 4, 2 means 2. Is 20, 4 means 16. Is it correct? 1629. Check once. 1629 plus 427. 2056 is coming, right? The answer is what? 1629. These many numbers are there. The from 1 to 3000, which are divisible by either 3 or 5 or 7. Check when it's correct or not. 056, yes, correct. 1629 numbers is possible. Okay, I hope everyone understood, right? Okay, fine. Let's do the last questions today. So, number of 4-digit numbers that are less than or equal to 2800 and either divisible by 3 or 11. So, how to do this? You can see, student, here is the 4-digit number, right? The 4-digit number is start from, here you can see 1000, right? To, what is that? 2800 you have to calculate. First, you have to understand how many numbers less than 2800 which is divisible by 3 first you calculate, right? So, let's see, first you can calculate the number of numbers till 2800 which is divisible by 3 you can calculate. That means what? 2800 by 3 you can use. Greatest integer function of 2800 by 3. How much it will be? So, you will get 933, you will get it. Greatest integer value. Okay. So, we need actually 4-digit number. The 4 digits number means start from the 1000. Less than, we are collecting less than 2800. So, that means 1 to 2800. How many numbers are divisible by 3 we calculated? That is 933 number is there. But we need only the 4 digits number. So, you have to subtract the 3-digit number 1 to 999. That means So number of numbers till 999, which is divisible by 3. So first you calculate how much it will be. 999 by 3. So how much it will be? 333 numbers possible. So therefore how many 4 digits number? Therefore the number of 4 digit number of 4 digit number between 1000 and 2800. How many number is possible here? You can see 933 minus 333 number is possible, because we need only the 4 digit number, right? It is start from the thousands, we need that only. So okay, so therefore you have to 933 minus 333, you have to subtract. How much it will be? 333 you can subtract it. 600 number is there. It's a 4 digit number which is divisible by 3. Understood? Fine. So next, number of numbers till 2800 which is divisible by 11, you have to calculate. Number of numbers till 2800, right? 2800, okay, which are divisible by, that means 1 to 2800 I am taking, right? Which are divisible by 11. That means what? The larger number is 2800 divided by 11. You can calculate this one. What is that? 254. The greatest integer value is what? 254. The 254 number which is divisible by 11 from 1 to 2800. Okay. Now we need actually 4 digit number. So now you have to remove the number which is up to the largest 3 digit number, you have to remove it, right? So therefore number of till 999 which are divisible by 11. How much it will be? It's not writing. So 2800, sorry, 999, no? The largest 3 digit number is 999 only, divided by 11. So what will get? So you will get 90, right? 90 is the possible. Okay, we need only between 1000 and 2800. Then only you can find the 4 digit number, right? So we need number of numbers between 1000 and 2800. So how many number is possible here? 254 minus 90. How much it will be? Yes, 254 means 164 will come, right? So therefore how many 4 digit number which are divisible by 11? So 164 number is possible. But one thing you have to remember, students, here inclusive-exclusive principle you have to apply. So which things you have to remove it here? Either 11, you can see either 3 or 11 is required. But you can see it's a multiple of 3 and 11 also is there. No, you have to remove that case. How many numbers? So how many number of numbers Next is what? Number of numbers. So till 2800 which are divisible by 11 into 3, that is 33. Divisible by 33. You have to take the LCM of 3 and 11 because we need completely either 11 or 3. We don't want that multiple of the combinations, right? Okay. So we need 4 digits number. So we have to remove the 3 digits, right? Number of numbers till 999 less than, that is 3 digit number, you have to remove it, right? Which are divisible by 33. So first case you can see, what's your answer? This will be greatest integer function of 2800 by 33. This will be the greatest integer function of 999 by 33. So you can see the answer. What is that? 2800 by 33 is 84. 84. So 999 by 33 is 30. This is 30. Clear? So we need actually the 4 digits number. That means the between 1000 and 2800 is required. So number of number. So you can take another page. Number of numbers between 1000 and 2800 which are divisible by 33. Then what will get? You can see. So we have to collect all the multiple of 33 from 1 to 2800, that is 84 number. 84 number. We need only 4 digits number. So you have to remove the 3 digits case, that is 30 number. So the answer will be here is what? 54. 54 4 digits number is possible which is divisible by 33. But actually is what is required. We need A union B. What is that? Cardinality of B minus A intersection B. This is actually what? Cardinality of A intersection B. This one. Okay. Cardinality of A is what? You can see, student. So where is cardinality of A here? Here is there. This one is the cardinality of A, right? Okay. The number of 4 digit number between 1000 and 2800, cardinality of A. Cardinality of B is what? 164. This is cardinality of B. And then cardinality of A intersection B, multiple of 3 and 11, that is A intersection B. You can do it 600 plus 164 minus 54. What's your answer? 600 plus 164, it's 4. This is 6, 764. 764, 54. How much it will be? 0, 1, 7, 10. So 7, 10 is your answer. There are 7, 10 4 digit number which is either divisible by 3 or 11. Understood? Not multiple of 3 and 11. Understood? This way we can apply the principle of exclusive and inclusive method, right? Inclusive means adding, exclusive means subtracting. I hope everyone understood. If you need these kind of standard kind of questions which is required for JEE Main Advanced, you can watch my channel continuously. I will update you many videos like this. I will post you in the channel. If you have any comment is there, you can put your comment in the comment box. Okay, and So please subscribe my channel. You can share to your friends so everyone will benefit through these videos. I hope everyone understood. So thank you everyone. Thank you very much.